I can see it.
All right. Well, hello everyone. My name is Mason House. I am a master student under Dr. Scott Nolte in weed science, and I will be presenting my master's research. I'll be presenting a pretty good bulk of it, not quite all of it, that centers on the evaluation of the impact of herbicides, equipment types, and methodology on smutgrass control. If you're not familiar with smutgrass, it is an aggressive perennial bunch type plant that we have here in the southeastern part of the United States. One of the best descriptions I've heard of it comes from my lab colleague, Zach Howard. He says that smutgrass plays an SEC schedule, but also plays a little bit out of conference. So if you're familiar with college athletics, Southeastern Conference, plus Oregon, California, and some up in the Northeast. One reason it's a very prolific weed is that it can produce 45,000 seeds per plant in 1 year. And the picture in the middle is a smutgrass seed head. And it's problematic due to its ability to invade Bermuda grass ranges and pastures, which causes a decline in the nutrition for beef cattle and makes it very difficult to traverse, which is what the bottom right picture is, just a field that's been overtaken by smutgrass. It is very difficult to drive through, very difficult to walk through, difficult for cattle to navigate. So it is very advantageous for us to control it. And the overarching goal of my experimentation is to determine ways to increase herbicide efficacy and therefore smutgrass control without necessarily increasing the amount of herbicide applied. So I used a total of 5 herbicides throughout my tenure of this project. Any use of the trade names in this is not an endorsement. It's simply included for research transparency because there are some different formulations of these products, and I'm not speaking on those formulations. I can only speak on what I've personally seen. But I use hexazinone, glyphosate, imazapic, indaziflam, which is a pre-emergent, and a C8C10 fatty acid blend, which is an organic herbicide. I'm going to do background on the main 2 that I used, which are hexazinone and glyphosate. You'll see that they recur throughout this presentation, and I'll explain why they are recurring. First, hexazinone was it was first registered as a pesticide in the US in 1975. In this research, it's under the trade name Velpar. There is another formulation of hexazinone that is a little bit stronger. Velpar is 2 pounds per gallon of hexazinone. The other formulation is 2.4. The reason it's important to know the weight of hexazinone in the formulation is because the federal mandate is that there's no grazing restriction for beef cattle if you're under 1.26 kilograms of active ingredient per hectare. So but it on the label of Velpar, it recommends 3 to 4 gallons per acre for complete control of smutgrass. And that obviously, if you go that high, you're going to be above 4.5 pints per acre. And my key focus is to increase control without exceeding the 4.5 pints per acre, because I'm focused on beef cattle. All of the places where I did research have beef cattle actively on them, and it seems like they take the hardest hit from it. And it requires rainfall for activation. The label is very specific about that. It has to be more than 24 hours after application, but less than 7 days after application. And if you don't believe me that it says 3 to 4 gallons an acre, here's the label, and 2.5 gallons per acre is $360 per acre of this formulation. So 360 gallons per acre, we're going to try to stay away from $360 per acre, rather. Trying to stay away from that. Another herbicide I used a lot of is glyphosate. Was first registered in 1974. It's non-selective. And the main bit of research that was focused on in glyphosate is that research shows it takes 5.6 kilograms per hectare to completely eradicate Bermuda grass. And since I'm trying to save the Bermuda grass, my focus was to determine if there's some sort of window between the amount of glyphosate that it takes to kill a smutgrass plant, which is not known at this point, and but see if it is less than 5.6 kilograms per hectare, or if there's any sort of variable within application that can make that happen. So the first trial that I will discuss was initiated in April of 2019, 4 replications at 2 locations, and one in Anderson and one near Richards, Texas. It's a total of 12 treatments plus an untreated control. All of the liquid herbicides, which are the first 3 bullets in the middle, were applied at 35 milliliters of solution per plant in 3 different rates. These rates are 1, 2, and 5% of their product rates. That's where the numbers came from. And then hexazinone tablets at half a tablet dissolved in 250 milliliters of water, half a tablet just placed in the crown of the plant, and 1 tablet placed undissolved in the plant. Visual ratings were taken every 30 days and analyzed. I believe everything in this study or in this presentation will be using Duncan's multiple range test and SAS. So here is a graph, top graph being smutgrass control, the bottom graph being the Bermuda grass tolerance to the herbicide treatment. And in terms of smutgrass control, I had all of the treatments not significantly different except for one was glyphosate at 1%. Product solution was significantly more than the untreated check, but significantly less than every other herbicide. And then in terms of Bermuda grass tolerance, we would generally expect these graphs to go down as the herbicide rate increased, which the glyphosate did, and the hexazinone tablets did about what I would expect them to do. But then if you notice the hexazinone in the middle and the imazapic plus glyphosate in the middle, the middle rate is less than the 2 around it. And so that means that there's some sort of other variable within the application that caused efficacy to go down, because it is not directly correlated to the rate. And this is essentially 8 replications, 4 at 2 locations. And I'll try to figure that out later, and maybe I have an answer for you. So interpretation of those results, all herbicide treatment significantly controlled smutgrass compared to the untreated check. All treatments that did not cause significant Bermuda grass injury were hexazinone. Anything that included glyphosate did cause significant injury to Bermuda grass. And glyphosate at 0.217 grams per plant was the least control. It was the one that was significantly lower than the rest, but it was the most cost effective given the just inexpensiveness of glyphosate. Below, I have 2 pictures showing what I mean when I say smutgrass control and desirable grass tolerance. Around the glyphosate, you can see the dead clumps of smutgrass plants, and you can also see rings around them from the herbicide killing the Bermuda grass around it. But then if you look at the hexazinone treatment next to it, notice how the Bermuda grass goes right up to the edge of the dead smutgrass plant, just due to the Bermuda grass's ability to tolerate the hexazinone much better. Next was a pretty neat one that was undertaken in partnership with the USDA ARS, which was a comparison of an unmanned aerial sprayer and hand-applied individual plant treatments. So when I say unmanned aerial sprayer, the left is what I'm talking about. This machine was approximately 6 feet across from propeller to propeller. It can hold 10 liters of spray solution, and it sprays from a height of about 6 feet in the air, as opposed to the right, which is what I would call more conventional method of individually treating plants, of standing there with a spray gun. I was looking at a stopwatch on my wrist is what I'm doing right there. And that, yeah, so basically a comparison of the future to the current conventional standard. Pros and cons of the two. UAS is not sensitive to terrain differences. It can be if you have the settings set to keep it a certain height above the ground. But the way we were using it, we had it set to 6 feet high, regardless of the terrain. It reduces operator exposure to the herbicide because you can send it out and let it do its thing. And it allows for application from shaded or air conditioned area. Whereas if you're on the ground, you have to be out there wherever the plant grows at, and they don't grow in the shade. But you can physically put the herbicide on the plant, which is going to make it slightly more accurate. It's much less expensive to apply it from the ground. Cons of UAS is the one that we use costs $12,500, and it has modifications to it that would drive the price up even more. It will require extensive licensing as opposed to ground application, which can require extensive licensing. And it's going to be much more sensitive to weather conditions than a ground application. This study had 3 different herbicide treatments, each sprayed through the 2 different application methods, both at 2 locations with 4 replications each. One of those locations being the same as the previous study. The ground applications were made with a backpack sprayer. UAS application were made with the TTA M6E agriculture drone. Notice that the numbers of the UAS are much higher. It's a bigger nozzle and a more powerful pump. The reason for this is because the UAS is applying in an area about 6 square feet, whereas a smutgrass plant is only 3 square feet. So to ensure that both of the applications are putting the same amount of active ingredient on the plant, it is spraying twice as much liquid over twice the size of an area. So at 2-second applications, it was putting out 70 milliliters, whereas I was applying by hand 35, but 35 milliliters of solution was making it to the plant. I'm not going to play this video because I'm on my laptop and it has a hard time running it, and I don't want to crash this presentation. And it more so just serves as a picture of what the UAV sees. And then this shows what I would see lining it up over the plant. That's how high it sprays from. The nozzle is right in the center, and we would just spray right down on it. Here is smutgrass control. Glyphosate by hand significantly outperformed every other herbicide besides glyphosate plus hexazinone by hand in 30 days after treatment. The hexazinone treatments were significantly less injurious to the Bermuda grass than anything that contained glyphosate, which is the same result as the last study of just applying by hand. This is only 30 days after application. Notice that smutgrass control goes down and desirable grass tolerance goes up. We'd really like both those to be 100%. In terms of comparison between hand and UAS methods, glyphosate by hand provided more control than glyphosate with UAS. All the other herbicide efficacies did not matter or did not vary depending on methodology. But unfortunately, this is only 30-day application, 30 days after application. Upon returning from a trip where I had ensured that the cows were not going to get in with my plants that have been treated, I came back, and at both locations, I don't know if it was something in the shift of the weather or plants breaking dormancy, because this is right at the time they were breaking dormancy. The cows got into both locations and destroyed them. And rather than piece together the crime scene, I had learned a lot about using a UAS and was prepared to do it again in 2020 with the help of USDARS. And then, unfortunately, as if you're just now learning about COVID-19, I'm glad I could present some new information to you, but we had a pandemic occur that made working with the USDA impossible, and they are the ones that own the UAS. But Dr. Dan Martin at USDARS is still experimenting with drones and has made a lot of strides. And I would love to, finalize this one day, do it right. Impact of equipment and methodology on hexazinone efficacy. The top part of this study, or this slide rather, is from broadcast applications using two different nozzles. One of them being a nozzle that sprays forward and backwards, which is the turbo twin jet. The second one being a unidirectional 30 degrees forward nozzle, the turbo T-jet induction. And then also using the same herbicides and individual plant treatments, and looking at whether spraying it directly onto the plant or around the base of the plant has any sort of effect on how well it works. And for this one, I'm using the rate that didn't seem to make sense in the first study to determine if there could be some sort of correlation between the application method and why it would have not fallen in line. Here's a picture of the nozzles used in the broadcast study. You can see the blue one spraying forward and backwards, the red one only spraying forwards. They are different colors because they're different orifice size, and the reason for that is because the twin jet, I use smaller orifice and slower speed to ensure the integrity of the swath. In terms of whether spraying around the plant or on the plant has an effect on efficacy, in terms of controlling smutgrass, it did not. But in terms of how injurious it was to the desirable grass, it did significantly decrease the damage to the Bermuda grass by applying the herbicide directly onto the smutgrass plant. In terms of whether the equipment affected a hexazinone efficacy, there was no significant difference in terms of smutgrass control or desirable grass tolerance, regardless of nozzle. But it is important to note that through both nozzles, neither of the hexazinone did not cause significant injury in broadcast, but it did in individual plant treatments due to the nature of, you're putting the herbicide in a very small location. And I got very similar results to a study done in Florida, and the pictures below show, you can see lots of yellow smut grass in that picture, and then the green around it is the Bermuda grass, and then the hexazinone around, you can see dead Bermuda grass about 6 inches off of it, whereas hexazinone on it, the Bermuda grass gets right up to the plant. Further results interpretation. The most important aspect to account for when deciding on an application style is the density of the smut grass. Really, the reasoning for this is labor expenditure and the law. If you're restricted to 1.26 kilograms per hectare, you have to make sure that you're accurately counting plants and knowing how big your area is. And if you would like to get 100% control, which is what I've gotten multiple times in individual plant treatments, but if you're spraying a lot of plants over a large area, it's just not feasible. In the individual plant treatment, direct correlation to herbicide rate was seen with some herbicides, but it wasn't with others. Part of this could be due to the application method. In April of 2019, I was a very young spry wheat scientist, so I have, gotten better over the last 2 years in my application methods. So if someone were to tell me that the application could have caused that difference, I would not discredit it. But I do think I've gotten better over the last 2 years, I guess almost 3 years now. Individual plant treatments did well across the board, and the key to being successful is to ensure that you're applying it correctly. UAV study, build better fences would be the first thing. And then also, I believe there's a lot of room to create more robust identification techniques. I would say that a UAV would also be very successful with that, at taking high resolution images from above, and also some sort of geocaching to mark them to be able to find them, whether the flag and the stake get broken by cows. Was I successful? I did establish baselines for different amounts of herbicides for smutgrass control and Bermuda grass tolerance. I did that. I was successful at using these herbicides through different application methods, which the entire scope of this was to look at different application methods to see if it affected the hexazinone efficacy. I did that. And do I think I discovered something completely new and novel that will contribute to the body of knowledge, which is the grand scheme of a master's project? I do believe I did. I was not able to find any published research using UAS to apply hexazinone, and although that did not go exactly as planned, I do believe I learned a lot about how to be successful with this 21st century technology. I learned that regardless of nozzle, between these studies, other A&M studies, and literature, around 75% control is what you're going to get from hexazinone at the 4.5 pints per acre broadcast. You can get better control out of hexazinone by doing individual plant treatments. However, to get better control while remaining at 4.5 pints per acre broadcast, I have some data that shows that adding glyphosate in combination or sequentially to hexazinone can increase this while remaining below a grazing restriction threshold, and also not glyphosate is not $369 for 2.5 gallons, so it can increase control without exponentially increasing cost. This research is not presented because the second year and second location will be collected this spring. Also, in combination with research done by Zach Howard, who is still here with us in Extension Wheat Science, I have reason to believe that indaziflam can be useful to prevent smutgrass seed emergence. The second location and second year of that is also in the process of being collected. So I have research on using hexazinone and glyphosate separately, mixed and sequentially. It's not, both of these two are not presented due to their second location not being finalized. The data, this research I did on the organic fatty acid herbicide is not presented. The key from that is that 60 days after treatment, the smutgrass, there was no significant difference from the control. And then the nozzle study poster of which is the evaluation of nozzles using hexazinone and glyphosate, I have presented the first years of that data at 2 conferences so far. So if you scan that QR code, it will take you to that poster. There are my citations for my literature. Special thanks to Dr. Nolte, Dr. Hagen, Dr. Skaggs for being on my committee, Matt Matoka and Zach Howard for being great helpers, Dr. Renchi for helping me since before I was employed by AgriLife, Dan Martin from USDA, Bill Thomas, General Randy House, and Nick Filippello for allowing me to conduct research on their land. And the floor is now open for comments, questions, concerns, or rumors that need to be squashed.
Interesting seminar, Mason. Very good. Hey, do you think, was there any tornadic activity associated with that release of cows on your plot?
Yes, yeah. I basically think that my tornado was cows. So,
okay, a cownado.
Yeah, we had.
That's a good idea for a movie franchise, if I do say so myself.
Yeah.
Okay, let's open up for questions.
I got one in the chat, which is, what kind of Bermuda grass did I use for the study? Forage type or turf type? Have you observed any variations in herbicide tolerance in different Bermuda grass cultivars? No. So all of the Bermuda grass that was treated was what was there for the cattle grazing. Most of it was common. There was one of these that looked too good to be common, but the landowner didn't know what variety it is. I think it was probably coastal because it did look a little bit better than common, but it didn't look quite as good as something like Tifton 85. But variation of herbicide tolerance in different Bermuda grass cultivars, no, I don't have access to lots of different cultivars to be able to conduct a study like that. And then next chat question, maybe I missed it. How are you ensuring the area is getting equal quantity of active ingredients by different application methods? So is everything that was applied by hand in individual plant treatment was 35 milliliters of solution. And it's not really about equal quantity. Some of it is meant to get more, but it's, and then I guess comparing equal quantity of active ingredients between individual plant treatment and broadcast is not really feasible, just because that's that's why they're different application types. Is just because one of them allows you to put much more quantity in a much smaller area. Matt, should Scott F or Scott N consider a career in stand-up comedy? I don't have an answer to that one, so I'll open the floor up to any Zoom questions. I'm ready for some fastballs right down the middle.
You got one in the chat there.
I got chat. Is Smutgrass self-pollinated or cross-pollinated? Oh, I have not done any research on that. I would guess it's cross-pollinated, but I do not have any concrete proof to answer that question.
Hey Mason, it's my question. So if the Smutgrass is cross-pollinated, did you do the pollination control for each generation?
No, this was just naturally occurring Smutgrass out in a pasture. I did not do any sort of intervention with the breeding or reproduction of the Smutgrass.
So when you do the ANOVA, did you take the genetic variance into one factor?
No, I have no dealing with any genetics on it.
Okay, thank you.
Mason, this is
Oh.
Megan. I have to ask you a question just because we're old classmates. But so what about alternatives other than, I know your whole study is based on the herbicides, but are there some competing forage plants that could be a source of control of that? I'm thinking like ryegrass that competes with that to prevent smutgrass from being there in the first place.
So a good healthy stand of Bermuda grass can mitigate it quite a bit. That's probably the primary option for if I was going to tell someone how to keep it from becoming a problem, is avoid letting cattle graze the Bermuda grass down to the point where it's opening up the soil for it. The Bermuda grass is the primary answer to that. Really, this it starts to become a problem. So one of the reason we have a lot of smutgrass that's emerged in the last 10 years in Texas. One of the reasons for that is the drought of 2011. Lots of people bringing hay from areas such as like Louisiana, Mississippi, and Alabama that have a ton of it in their swamps. Because I know that a lot of the land that I've seen back home that has it, and then I know that the land in Brazos County that I'm doing research on, that it has it in very specific pastures where he fed hay that came from somewhere else. So the first option is to, make sure that you're buying weed-free hay. And the second option would be not letting the cattle, and one of the reasons that it was allowed to, take over is because in 2011 we were in a drought. So there was basically no Bermuda grass to cover the ground to stop it. So yeah.
Great answer. Thank you.
Is there any research being done here at A&M on fire for weed control? I do not work on any sort of fire for weed control. I've definitely sat and listened to presentations from somebody in South Texas, one of the South Texas agents using fire, but I don't recall what weed it was on, and nothing that I have experience with.
All right. Other questions? Perfect. I'd like to thank the speakers again for doing a great job, and the audience, great audience. Join us again next week, same time, same channel for another episode. Signing out.